In this video, I'll be discussing how I test capacitors, all different types of caps, how I figure out whether they are leaky or shorted, and whether the values are the same as what's actually stated on the cap. For this, you need a multimeter, something that can do resistance and capacitance as well. You could use a modern multimeter like this. I would advise, if you are going to test high voltage caps, to use a slightly old meter like this Avo, which puts more than a couple volts at least between the component, something to work out at least if it's shorted. Obviously something like this can't do capacitance. I suppose another tool you could use is a capacitance and resistance bridge, very good for checking components, but those don't seem to come up as often as they once did. So we will be using this modern meter for this demonstration. I've got a selection of different components here. This is a modern high voltage cap rated at 150 mic. It's a 400 volt capacitor, and this should read well over sorts of 3 megs. It really should be infinity, or at least should read as an open loop. But if you have a meter which can read up to 10 megohms or something, you should get a reading on it. So first, if we look at the resistance, you want to ensure that you're connecting the cap the right way around. So negative end, positive end. And so what we're looking for, as I said, is for a reading of open. Let's ensure that things are reading. See, that's reading a short on my meter. You see that we have 0 ohms which come up, which means it's well into the meg range. It's a very good cap. If we go into the capacitance mode, so that's 100, it's reading 137 microfarads. Remember, these things aren't too terribly accurate, and that's within 10 to 15%. So I think that's more than reasonable. I've got some old capacitors here. So these are all 0.01s. We test a new 0.01. We can compare it with the old ones. So this would be in nanofarads. So it should come up as 10 nanofarads, which it's doing, as you can see. That's about 10. So actually that's well on the money. And if we look at the resistance, again, that reads an open loop because this is a very good cap. If we compare that to, knowing that now, we can compare that to something like this, which is a Sprague. These used to be very high quality capacitors. I'm not too sure whether they would hold up. I do keep them still in my stash, and in fact I do use old caps every now and again for certain purposes. And you see that also reads as open, which is quite interesting. That implies it's reading over 10 megs. If we go into the capacitance, it's reading just over 10 nanofarads, so it's near to a 0.2, to be honest, but that's not too bad. That's quite good, to be fair, considering that sometimes these capacitance meters aren't always accurate. These are very good capacitors as well. I think these might be TCC branded. That's a TCC branded cap. If we test this, that is reading pretty much bang on the money, so that's a good cap as well. And if we look at the resistance again, that also reads into the megs. It's just something I found. I don't know whether this is a good cap or not. I had it in one of my boxes. 100 to 200 mic. Red outer is 100, so that means yellow is 200. If we do red first, so it's creeping down very slowly, if you can see. Anything under, I'd say, about 3 megohms is probably not worth it. Okay, that's falling slowly, but it is dropping. Let's see what the capacitance is like. So 107 mic, slowly rising. This implies that it's good because it's obviously within the 10% range. Obviously these things were never that accurate. We can also read this other section here. So this is telling us that the second section of this cap might be slightly leaky. You see how the value is way beyond what it's supposed to be. This can imply that the cap is leaky, and if we look at the resistance, that would probably confirm it to us. See, that's dropping very quickly. Anything that's under, I'd say, about 5 is probably not worth it, to be honest. If we're talking anything modern, anything that reads open but has a capacitance to it is fine. Anything that's 20 megs or over is all right. For some of the older stuff, valve radios and things, there's nothing wrong with using something like this as a smoothing cap. Now, these are quite dubious. They do go bad. In fact, I think this one has actually gone bad. We can confirm that with a resistance reading. This is going to be well under a meg. This implies that the capacitor is shorted. The capacitance will be well off as well. You see it's rising. It's going beyond like a 10% value here. This cap has snuffed it. Some of this old stuff, it could even work, some of it can't. These Dublier type caps, they tend to suffer from this, and it's all to do with the condition that they're kept in. If you were to cut this open, it would be a metal tube in here with an end cap. So that's probably not worth trying to salvage. This is something I've in a carton called low microfarad old caps. We've got all different types here. We've got cardboards, something like this, which we know is going to be leaky because it's contained in cardboard. I think it might be a 25 mic because it's polarized. We can test it. Let's do the resistance first. This method works really well, and I've been using it for years. Let's see what type of value we get. Yeah, look at this. So obviously this cap is completely gone short, and if you were to put it across the supply, it would short out the supply. The cap would get very hot, and it would probably cremate any form of rectifier you have in the circuit, and obviously wouldn't smooth anything, and your volts would drop and actually go across this cap and completely short it out, and probably cause a lot of smoke to erupt out of it and horrible fumes which you'd want to breathe in. And for the capacitance value, 25 mic is the value we're going for, and this reads nowhere near it. 9, 10, yeah, that's completely gone. But this is what I'm saying. If the value isn't within 10%, the cap's gone, which is another way you can sort of tell, as well as measuring the resistance. Anyway, that's how I test old capacitors. I've been doing it this way for years, and it's worked out pretty well in my favour. I don't think it's ever proved me wrong. Anyway, I hope that this has helped someone out there. I'll hopefully be posting some more videos soon on vintage television and monitor repairs, and a couple fault finding guides and tips regarding doing such things, and going over some tools and other items which I use on a daily basis. Cheers. Thank you, guys.